Hello, welcome to this series. In the last video, I was discussing about charging and discharging action, right? And we have already discussed about the charging and we discuss about discharging, but I promise you I will discuss related to the time constant, right? Now, if you see this expression, in this expression you will see this capacitor is getting discharged, right? Q is equal to Q naught e to the power minus t by RC. If we plot this, here, this is your time axis, this one is your charge axis. Then what will happen? This is simple. E to the power means y is equal to e to the power minus x relation, right? If you increase x, this y will decrease exponentially, right? Now this is similar to this. Here you have some constant, right? Here you have some constant, means this value, this q will never get beyond the q naught. Okay, just then put a boundary over here, means that is the maximum limit for q to achieve. All right, so this point is nothing but q is equal to q naught. Okay, is equal to q naught, right? And then what will happen? Here you have a maximum charge and then it will get discharged slowly, right? It will get discharged slowly depending on your RC constant. It will discharge like this. Okay, right? Now if you just take an instance like when t is equal to RC, what will happen at this time? Then q will be equal to q naught e to the power minus 1, right? Oh, sorry, yeah, e to the power minus 1. It means q naught by e, means at a time t is equal to RC, let's assume this time t is equal to RC. Okay, t is equal to RC. You will have R and C in the circuit. If you multiply R with the C, you will get some time, right? At that time when t is equal to RC, then Q will be equal to Q naught by E. E will be there between 2 and 3, right? 2.3 or something, means 50 or 60% it will get discharged, right? Approximately 60%, whatever value of E, I don't know what will be the value of E. You can calculate. Let me check in my calculator, or any which way you can calculate and you will get the value. Okay, and at t is equal to 2 RC, right? At t is equal to 2 RC, when t is equal to 2 RC, what will happen? Your q, in this way, your q will be equal to q naught by E square. Okay, here it is E, value of E will be 2.3 or something. Let's take approximate value. I don't remember the exact value of E. I know, yeah, E should be greater than 2 and less than 3, right? This is what I know. Approximately 2.3. Let's take 2.3, right? 2.3 means approximately half, right? Just for simplicity, half means yes. And then E square again, and when t is equal to 3 RC, then your q, means here q will be equal to q naught by E cube. Okay, this RC, see, RC and 2 RC, 3 RC, this RC we call time constant. This we call time constant. Time constant. Okay, this is, we can say, in first time constant your charge will get discharged up to q naught by 2.3, and at 2 time constant I will represent this as the t naught. T naught, right? At t is equal to 2t naught q naught by e square. At t is equal to 3t naught q square by e cube. At t is equal to 5t naught, what will happen? Q will be equal to q naught by e power 5, right? E power 5 is a huge value. In first time it was like q naught by 2.3, and then again you have this value and q naught by e power 5. It means you got very small value now, right? And this value will be approximately, it will tends to 0. It will tends to 0. So in general we will say, after 5 time constant the charge, the capacitor will get 99% discharged. Capacitor will be 99.99% discharged. At t is equal to 5 t naught. That is very important relationship. At t is equal to 5 t naught, this will get discharged up to 99%, 99.9%. Similarly for charging also, means at t is equal to t naught we will get charge e into q naught, and then e square, e cube, and then finally at t is equal to t naught it will be fully charged, means 100% charged. Okay, so this is the basic concept of the charging and discharging, and in the next lecture we will solve this problem, right? We started with this, we'll solve this problem in the next lecture. See you in the next video.